All right, everybody, welcome back. We're going to continue on our Pre-Calculus 11 notes. Today we're working on trigonometry, and we're going to keep on building on what we did last lesson as we solve trigonometric equations. So let's take a look at something that seems relatively simple here. It says solve to the nearest tenth of a degree. And you can see here that it's given me a sort of a range from 0 all the way up to 360 degrees. And we're going to come back to that in a second. The first one here is the sine of theta is equal to 0.7562. So I know that if I have the sine of theta, the way that I can get rid of that, kind of my algebraic step to eliminate that, would be to take the inverse sine. So theta would equal inverse sine of 0.7562. And so if I go to my trusty calculator here, and I'm going to make sure that I'm in the right mode, so I'm just going to check. I'm going to make sure that it's on. And then I'm going to check the mode that I'm on. I can see I'm in radian mode. So again, I'm going to go down and then over and hit enter and make sure that I'm in degree mode. So if I put this in my calculator, second function sine of 0.7562, and then I hit enter, the answer comes out as 49 degrees. And I'm going to go to the nearest tenth of a degree, so 49.1. So I get 49.1 degrees. The thing is, though, is that's actually not the complete solution, because what we learned in the previous video is that for a given reference angle, as you move around the unit circle, that reference angle can have the same value in different quadrants, or I should say the sine of different angles can have the same value. And so, for example, if I was to draw a little picture here, I've got 49.1 degrees. So 49.1 degrees is something like this. 49.1. And so what I remember is that I've got this mnemonic that reminded me that all students take calculus. And by that I mean this angle right here, 49.1 degrees, if I move into the second quadrant, I would actually get the same result from a different angle over here. So if I have an angle here in the second quadrant that had the exact same reference angle, which is this here is 49.1 degrees, then this angle will return the same value if I take the sine of it. And so how would I find that? Well, that angle right there is going to be, let's see, the whole line is 180, but if I did 180 degrees minus 49.1, I would end up with, let's see, 130.9 degrees. And so, in fact, there are two solutions to this. If I just go back to my calculator and check really quickly, if I take the sine, so if I take the sine of 49.1 degrees, you can see I get pretty close to what was my original question. Now I'm going to take the sine of 130.9 degrees, and you can see that we get that same value. Now it's not exactly the same because I did round off to the nearest tenth of a degree, but you can see that both 49.1 and 130.9 return the same value because they both have the same reference angle. Now they're also both positive, and so I'm not going to bother checking the third and the fourth quadrants because I know that the sine of anything in those quadrants would return a negative answer. And that's where we come back to this point from the very beginning here. Whenever you're solving for an angle, you have to specify over what range you're going to look, because if you can look all the way around the circle, then there will always be at least two answers, or there will always be almost always two answers for any given angle. And of course, if you're allowed to go twice around the circle, then you would keep finding multiples of those answers and so on. So the steps we're going to follow here is one, we're going to identify the quadrant and sketch it out. So we're going to draw a picture first, actually. And then we're going to find the reference angle using our trig ratio. And then last step is to find the solutions. And again, there's often going to be two solutions over a full rotation. So let's try the same thing for the cosine of negative 0.2491. And so my first step is I want to draw this angle here. So I want to try and draw this angle. Now I don't know what it is, but I'm going to go to my calculator and I'm going to find second function cosine of negative 0.2491. And it's going to return an answer here of 104.4 degrees. So my calculator tells me that theta, which is the inverse cosine of negative 0.2491, is 100 and, let's check that again, it's 104.4 degrees. So that angle, 104.4, is going to be over here in the second quadrant. So maybe something kind of like this. So there's my 104.4 degrees. Now this makes sense because I know if I follow my all students take calculus rule, I'm not surprised that I get a negative answer here in the second quadrant. And then I might ask myself, okay, well then what other quadrant am I going to get a negative answer in? And the other quadrant would be the third, because cosine is going to be positive in the first and the fourth. So I need to find now this angle as well. What would have the same reference angle but would be found in the third quadrant? And the way I'm going to do that is I'm going to identify my reference angle here based on my first little picture, my first angle. So if this is 104 degrees, then this angle right here, my reference angle, is going to be 180 minus 104.4 degrees, which will be 75.6. Now here's where we have to be careful. The answer is not 75.6. And the reason is, like, let's just go over here, just jump on the calculator again real quick. If I take the cosine of 75.6, I'm going to get an answer that's very close to what I started with, but it's not negative. It has to be negative. So when we find the reference angle, that might be one of your answers, or it might not. What I actually want is I want this bigger angle here that's drawn in red. And so that angle is going to be, that angle that I'm looking for is going to actually be 180 plus my reference angle, which is 75.6. So that's 255.6 degrees. And so there's two answers for theta. Theta can be 104.4 degrees, like I found originally, or 255.6 degrees. And those are my two solutions. You'll notice that it was a negative, and I got answers in the second and the third quadrant, which is kind of what I expected. Okay, last but not least, we've got a tan function here. So I'm going to draw my little grid, my little axes, and make a plan. So the tan of theta is negative 5/3. So let's see what my calculator says. It says the answer is negative 5/3. I'm going to take inverse tan. And so I'm going to go to the calculator and go, okay, inverse tan. And I'm going to do negative 5 divided by 3, close my brackets, and it spits out the answer of negative 59.0 degrees. So negative degrees, well, that works the same as regular degrees. You just go in the opposite direction. So normally I would go counterclockwise around the unit circle. Now I'm just going to go clockwise 59 degrees. So this angle right here, this angle corresponds to negative 59.0 degrees. And so note that this is not one of my answers because negative 59 degrees is not between 0 and 360. So it gives me the reference angle, but it doesn't actually give me a solution. I know that tan is going to be negative in the second and the fourth quadrant. So the two angles I'm actually looking for here are going to be this one here in the second quadrant and this one all the way around here in the fourth quadrant, but by going in the normal direction, going in the positive direction. And so maybe I'll just call them theta 1 and theta 2 just to organize my thinking here. And so I'm going to have theta 1, we can see, is just into the second quadrant where the reference angle is 59 degrees right there. So that would be 180 minus 59 degrees, which is going to work out to be 121 degrees. And then to find theta 2, I can see that my 59 degree angle is this one right here, because that's what I found with my original. It was negative 59. And so this theta 2 would be 360 minus 59 degrees, which would be 301 degrees. And so my solutions are 121 and 301 degrees. Okay, so we've got a couple other examples right here, and we're just going to do the first one, and then I'll leave the other one for you to do in your own. But basically, we have to always consider any restrictions that we've been given, okay? So in this example, we've been given a slightly different restriction. The first one, it said, look, you just take anything around the unit circle, and this one around, we're going to restrict it. So we're only going to accept answers that are between 90 and 270 degrees, okay? So we're looking for an angle where the sine of that angle is -2/7. So we're looking for an angle where the sine of that angle is -2/7, but we've restricted it so it can only be in the second or the third quadrant. So I can't have anything in here in the first quadrant, and I can't have anything in here in the fourth, okay? So let's see what happens. So when I find theta, that's going to equal inverse sine of -2/7. Let's see what the calculator tells me. So second function, sine -2 divided by 7, and that's going to equal -16.6 degrees. So -16.6 degrees. Now your calculator will sometimes give you an answer that is in the second quadrant or the third quadrant, and sometimes it'll give you an answer that's a negative. You just have to be able to kind of roll with either one. And so this reference angle right here that's given to me is -16.6 degrees. Well, that's obviously not a solution because it doesn't fall within the range that I've been given. I can only give an angle that's bigger than 90 and less than 270. But I can see that the sine of the angle is going to be negative, so I know that it's going to happen here in the third quadrant. So it's actually going to be this one here that ends up in the third quadrant. It can't be in the second quadrant because sine is always positive in the second quadrant. And so if the reference angle is 16.6 degrees, then that total angle theta would just be 180 plus 16.6. So 196.6 degrees is my answer. Now, note that there's only one solution here because of the restriction. If I was allowed to use the full circle, I would have found another answer in the fourth quadrant, but that's just not part of it. So that's how we solve our problems, how we solve for angles over a given set of restrictions. Sometimes we have to do a bit of algebra first. Okay, so if I give you a problem like the following, and it says, okay, 5 tan theta plus 1 equals 4. This looks horrible, but I just want to point out that if I actually gave you the question 5x plus 1 equals 4, you would have no problem in solving it. And so the fact that there's a little trig ratio in there doesn't actually change how we're going to go about solving these equations. So we need to isolate following our SAM-DEB rules, and then in the end, we're just going to have to get rid of the trig function by doing the inverse of that trig function. So I'm going to just follow my algebra steps, which I'm going to just subtract 1 from both sides. So I get 5 tan theta equals 3. And then I'm going to divide by 5, and so I get the tan of theta equals 3/5. And now to solve here, I just need to take the inverse of the tan function. So theta is going to equal inverse tan of 3/5. Now when I plug that into my calculator, second function tan, 3 divided by 5 is going to equal 30.96. Let's just round that off to 31.0 degrees. So my calculator tells me 31.0 degrees. That is not the only possible solution because I'm given it over a range from 0 to 360. So remember, your calculator is only going to give you one answer. It's probably going to give you the simplest answer, which is great, but that may or may not fit your restriction. So I found here that I've got 31 degrees is my first answer, which is, it is one of the answers. It's also the reference angle, but I have to find the other angle where I'm going to get a positive value for tan. And so I know that's going to happen here when I go all the way around the circle into the third quadrant here, because tan is also positive in the third quadrant. And so my second solution is going to be 180 degrees plus 31 degrees, which is 211.0 degrees. So I've got two solutions. I've got 211 degrees and I've got 31, and they both work. Okay, I'm going to leave those other examples for you to practice on your own, because the last thing I want to talk about here is I want to talk about solving equations with special or quadrantal angles. And so you should be able to do this stuff without a calculator. You should be able to just kind of work it out. So we'll do a couple of these as an example. So I've got sine of theta equals 1/2. Well, I know that that angle is going to be located somewhere in the first quadrant because the sine of the angle is positive. And so I could draw an angle like this where the opposite side is 1 and the hypotenuse is 2. Well, right away, I'm going to recognize this as being one of my special triangles, which is a 1 to 2 to root 3 triangle, which is my 30, 60, 90 triangle. And so this angle right here would be 30, and this would be 60. Okay? And so if it's a 30, 60, 90 triangle, then one solution for theta is that it is 30 degrees. And that's great. But what other possible answers are there? I'm going to look anywhere around the unit circle, anywhere from 0 to 360. And so what is the other place that I would return a positive value for sine? Well, that's going to happen in the second quadrant. And it's going to happen in the second quadrant with a reference angle of 30 degrees right there. And so if the reference angle is 30 degrees, then I can see that this overall angle here, from here around to there, my other angle theta would be 180 minus 30 degrees, so that would be 150 degrees. And so I'm going to return two possible answers. Theta can equal 30, or it can equal 150. Okay, we're going to do one more of these, and then we're going to move on. So let's try the cosine of negative 1/2. So the cosine of negative 1/2, I know that if it's negative 1/2, then it might be in the second and the third quadrant, because the cosine will be negative in the second and third quadrant. So if I draw an angle here such that the cosine gives me an answer, so the angle there, the adjacent side is going to be -1 and the hypotenuse is going to be √2, I can see this is my 1 to 1 to √2 triangle, which means this is a 45-degree angle. And so I can find this angle here. From here to there is going to be my first solution. And so my first theta value would be 180 degrees minus 45, which is 135 degrees. But there's a second value, which is going to occur in the third quadrant down here, where this is a 45-degree angle. Sorry, it's getting a little bit messy there. But I'm going to go from here around to there, to that point. And so I can see theta 2 would equal 180 plus 45 degrees, which is going to be 225. So I've got two solutions for my cos theta equal to -1/√2. Last but not least, I think I promised that we were going to do one more thing, but I lied because there's one more thing. And this is what happens if we've got a point, but we have to solve for the angle. So solve to the nearest degree between 0 and 360 if theta is an angle in standard position with a terminal arm point at -2,5. So solve to the nearest degree. Well, if I've got, so this is part A. So if I've got a point -2, so I'm going to go -2, +5. So there's the point, -2, +5, and that's the angle right there. So I'm trying to find what is this angle. This is what we're looking for. Okay. Well, I could find the reference angle because if I just go ahead and make my triangle look like this, I can see that this side of the triangle is going to be -2, and this side of the triangle is going to be 5. So I could find that angle right there. I could use, for example, tangent, because it's going to be opposite over adjacent. So the tan of theta is going to equal 5 over -2, or -5/2. So theta would just equal inverse tan. Oops. So theta would just equal inverse tan of -5/2. Now I'm going to put that in my calculator and see what happens there. So if I do, okay, second function, tan, -5 divided by 2, my calculator tells me -68. Okay, well -68 would be over here, right? This angle here is negative 68. And that's great, but that's clearly not the angle that I'm looking for. What it does tell me, though, is it tells me that the reference angle here is also 68. Right? So that angle there gave me negative 68. So to find this total angle starting from 0 and rotating around, then I could just say, well, that angle is going to be, so theta is going to equal 180 minus 68, and so this would be 112 degrees. Okay, that is it for solving trigonometric equations.